This is a combinations question from the Fitzpatrick book. I'm going to focus on question D. This is extension 1, by the way. I'm going to write the N with a K because it's really easy to mistake a M for a N. Okay, so let's just rewrite the question out. I'm going to explain each step. There's some difficult factorizations here, so I'm just going to explain those. The explanation at the back has some lines missing, and that's okay. If you're an experienced mathematician, you can skip those lines, but if you're just learning this, it may benefit you having an explanation with every line explained. Okay, so two sides to an equation, left hand side, right hand side. Let's see if we got this right. M plus K, choose 3, M choose 3, M choose 2, K choose 1, M choose 1, K choose 2. Okay, so let's have a look at the left hand side. By definition, if we have M, C, K, that is just the definition of combinations. So we have M plus K factorial all over 3 factorial M plus K subtract 3 factorial. By definition, we can simplify this just by iterating the top. Iterating just means expanding. Plus K in this context minus 1, M plus K subtract 2, and M plus K subtract 3. I'm going to keep the 3 as a factorial, M plus K subtract 3. Okay, I hope you can all see that we can simplify this. So we need to get the right hand side looking like the left hand side. So left hand side is equal to, we've got M plus K subtract 1, M plus K subtract 2, all over 3 factorial. Okay, so just take a minute, pause the video, and see if you can follow every step, because it's going to get a little bit complicated next. And if you're not with me so far, you're going to get lost. I would advise you to do this question with me, otherwise it's going to be pretty difficult to follow. Okay, so let's make a start. Let's get rid of that. Okay, so the first one was M factorial all over 3 factorial M minus 3 factorial by definition. The next one, we've got M factorial all over 2 factorial M minus 2 factorial multiplied by K factorial, that's my M again, K factorial 1 factorial K minus 1 factorial plus M factorial 1 factorial M minus 1 factorial multiplied by K factorial all over 2 factorial K subtract 2, and then on the end we've got K factorial 3 factorial and K subtract 3 factorial. Okay, so I hope you can all see that we can simplify this and this, and we can do that by performing one iteration of K to get K subtract 1 factorial, and the same here. 1 factorial is just 1. So this cancels. So we're just left with m and k. We can perform a simplification here as well. We can write m minus 2 and then m subtract 1, m subtract 2, and then m subtract 3. I'm squeezing it all in here to show you. Right. We can do the same here. M subtract 1, m subtract 2 factorial. Done the simplification there, done the simplification there. I quite like this method rather than writing them all out. It really shows us what we're doing, and we can get lost in translation if we can write them all out. K subtract 1, k subtract 2. That goes. Should be a factorial on the end here, and I hope you can see that the simplification here is going to be k subtract 1, k subtract 2, k subtract 3 factorial. So let's get rid of that. So let's write this down. Let's not do any more simplifications there because it's going to be really messy. So we've got m subtract 1, m subtract 2. The nice thing with these is that we know if we've made a mistake because we just don't get the proof right. Over 2 factorial. Don't forget multiplied by k. We have km here, k subtract 1 all over 2 factorial plus k subtract 1, k subtract 2 all over 3 factorial. Okay, so if we have 1 over 2 factorial and we need to make that 3 factorial, we can multiply numerator and denominator by 3 to get 3 over 3 factorial. Now our original was 1 over 2 factorial, which is just half. Let's see if we get half here. 3 over 3 times 2 times 1, half. Okay, so that is not the eraser. This is. So hopefully you're confident that we can change these into 3 factorial by just putting a 3 as a coefficient. Okay, so we're getting somewhere. So let's take the 3 out now. Let's factor the 3. We can't factor anything else yet. I think they're going to make us expand this. Okay, so let's do the expansion step by step. Okay, so we've got m squared subtract m subtract 2, 3km squared subtract 3km. Here we have 3k squared m subtract 3km. And at the end we have k squared subtract k subtract 2. Okay, so here we're going to get m squared minus 2m squared. Now I'm expanding all this step by step in the exam. If you want to take a shortcut, please feel free. But I'm showing all the simplifications just to aid those people who are new to this topic. So we got m cubed, rather, not m squared, minus m squared plus 2m. We've got 3km squared, subtract 3km, plus 3k squared m, subtract 3km, and then we're left with k cubed, subtract 2k squared. Is that right? K cubed, 2k squared, subtract k squared plus 2k. Okay, so pause the video and simplify this for me, please. I'm going to do the same. And let's see what you should get. If we simplify this, we're going to get m cubed. Let's write it in order. Plus k cubed. Subtract 3m squared. Subtract 3k squared. Subtract 6mn. Then we've got 3m squared n plus 3m n squared. These are not, these are k's. Plus 2m plus 2k. Okay, we are finally getting somewhere. We're finally getting somewhere. We can, to make this look a bit nicer, we can subtract and factorize. Now, okay, now, can everybody see that this can be written as, we can factor out 3 and then get an m plus k squared. Let me show that. M squared, if we expand this, square the first, square the last, double the product. And if we expand out, we get 3m squared minus 6mk minus 3k squared. So this is where that comes from. We can take out a 3mk here to get m plus k. Let's see if that works. 3mk squared. Yes, it does. And we can finally factor 2 out here to get m plus k. Whew. Now, the next thing we need to factor is the m cubed, k cubed. And there's a little rule for this. I'm going to write it down for you because it is pretty important. If we get something like x squared cubed, let's use a different one. X cubed minus subtract y cubed. In our situation, it is x cubed plus y cubed. This can be factored as x minus y, x squared plus y squared plus x y. If you expand that out, you will get the result. with ours, we've got x plus y, we've got x squared minus xy plus y squared. So the rule is wherever the sign is here becomes the sign here. So let's do that then. We can take m plus n is k m squared minus km plus k squared. Subtract 3m k squared plus 3mk m plus k, and then finally 2m plus k. So we are slowly getting there. Hope you can see now that we have a common factor, which is m plus k. So we're slowly getting the right hand side looking like the left hand side. So now we are left with, I'm going to write this in brackets, m squared minus km plus k squared. Subtract 3m plus k. Subtract 3mk, and just a lonely 2 on the ends. Okay, so we have done the most difficult parts. Okay, where do we go from here? So we have m plus k all over 3 factorial, and we need to simplify this. So let's have a go at doing that then. Let's have a go at doing that. This here is the same as m plus k squared, which is m squared plus k squared plus km, but we have subtract 3mk here, subtract 3mk, which gives m squared plus k squared minus 2mk. So I hope you can see, and if you can, please pause the video and check this, that this and this is just this. Then we have subtract 3m plus k plus 2. Okay, so we can factorize this. We can let u equal m plus k. So that would give u squared minus 3u plus 2. So that factors to u, subtract 1, subtract 2. Right. But we know u is equal to m plus k. Subtract 1. And m plus k subtract 2. So let's write that in. Let's write that in. So we got m plus k bracket over 3 factorial, m plus k minus 1, m plus k subtract 2. Okay, finally 20-minute proof. And this is our right hand side, and our left hand side after simplification was, let me just scroll back and look at the question, m plus k, color's not good, m plus k all over 3 factorial multiplied by m plus n subtract 1 and m plus n subtract 2. So we have done it, and this is Latin for what was asked to be proved has been proved, and that's quite a long proof. Very easy to make a mistake because there's lots of trickery. Just be confident that you can factorize this using substitution, and I think this was probably one of the more difficult examples of a combinations proof. So keep doing these proofs. It's really good practice for the exam, and good luck with your combinatorics.